NI's modular architecture allows you to specify and get a completely integrated test system using only the requirements of your product. Today we're going to be discussing how to determine which types of I/O you have on each pin of your product, how you would like those routed into the system where they're measured, and our innovative configuration process, which will allow you to receive an integrated test system without the hassle of having to write a statement of work. So in all likelihood, you've been customizing your signal types for years because there's been a lack of available off-the-shelf I/O solutions for the type of sensors and simulations that you require in an aerospace test system. We've created a comprehensive set of off-the-shelf hardware to meet most of the common I/O types needed in an aerospace setting. Now we could stop there, but that would still leave you with the task and risk of integrating multiple third-party products into a test system. Our architecture eliminates this risk. We've created a catalog, not of products, but of complete signal paths, all the way from the unit under test, back through the system to the software you're going to use to test. Once we know which signal types we're working with, we need to determine where in the test system they need to go. These are called endpoints. In an aerospace test system, there are a finite number of endpoints where you might want to route a signal to. The main destinations are fault insertion through a power bus or ground, parallel SIM-STIM, wrapping back out of the system, concurrent data acquisition, multiplexing to an instrument-grade measurement, or doing any of these while also routing through a load. Now that we have a complete list of signals, including the type of endpoint options required, we can take it from there. And I can develop a comprehensive model of your test system in software, which allows us to rapidly iterate on the design of the system as requirements change and become more mature. Additionally, because each signal type implementation is completely distinct and independent from one another, we can use an agile process to develop your test system. That means that even if requirements aren't 100% complete, we can still design, build, and validate a partially completed test system while allowing long lead items to become available and requirements to be finalized. Now I know what you're thinking. Not everything in the system can possibly be off the shelf. And you're right, there will be some things in the system that are customized. But even then, we use modular techniques that still enable our model-based design process to work. We'll discuss that in our next video. To recap, NI has a catalog of complete signal paths for the most common types of I/O found in an aerospace test system. Using our configuration process, we can bring those signal types into the test system and route them to the respective endpoints automatically. This also drives an agile, model-based systems engineering technique that allows us to make rapid, continuous progress towards your test system so you can test your product sooner.